All right, let's get right into it. Today, we're going to tackle a really cool question. How do you actually speak to a computer? We're going to follow a young coder from Abuja on his mission to figure this out. And believe me, by the end, we'll all understand the fundamental language of our digital world.
You know, you don't usually start a tech explainer with a greeting like this. Ikaro is a Yoruba way of saying good morning. It just perfectly sets the stage for a challenge that's going to be friendly, but definitely focused.
And here's our guy, Femi. He's 14, he's from Abuja, and he loves gaming and coding. But right now, he's got a huge challenge. To win a national competition, he has to prove he gets how computers think, right down to their very core. So let's follow his journey.
Okay, so Femi's first mission is, honestly, the most important one. He has to get fluent in the secret language that every single computer on this planet uses. It's their mother tongue.
So here's the biggest difference between how you and I think and how a computer thinks. We use what's called a base 10 system. That just means we have 10 digits to play with, 0 through 9. But computers, they use base 2. They only have 2 digits, 0 and 1. That's it. That's their entire alphabet.
And this system is called binary. You've probably heard of it. The real genius here is its simplicity. The best way to think about it is like a simple light switch. 1 means the switch is on, there's electricity. 0 means the switch is off, no electricity. That's it. And every single thing on your phone or your laptop, every photo, every song, every calculation, it all just boils down to billions of these tiny little switches flipping on and off super fast.
Okay, so if a computer only knows on and off, 1 and 0, how in the world does it represent a number that we all recognize, like, say, the number 5?
Well, let's break it down with this traffic light example. Imagine the code is 101. To translate it, you have to work from right to left. That last digit, the 1 on the far right, that's the 1's place. The middle digit, the 0, that's the 2's place. And the first digit, the 1, that's the 4's place. They're all powers of 2. So what do we have? We have 1 4, we have 0 2's, and we have 1 1. You add them up, 4 plus 0 plus 1, and what do you get? You get 5. And just like that, that's how a computer says 5.
All right, on to Femi's second mission. He's totally nailed the building blocks, the 1s and 0s. Now it's time to see how that basic language actually powers the tools we're using every single day.
You know, hundreds of years ago, people used an abacus to do math. Today, we've got a calculator app on our phones. But here's the cool part. Understanding binary shows you that these apps aren't magic. They're just doing that same simple on-off math we just walked through, but they're doing it millions or even billions of times per second.
Think about this vendor selling kilishi, which is this amazing Nigerian beef jerky. A computer adds up these big numbers in a blank. Why? Because underneath it all, it's just flipping those 1s and 0s at incredible speeds. It's all binary at its core.
So, for his final mission, Femi's got to tackle something a bit trickier. This is where we move beyond pure numbers and into logic. He has to take messy, everyday human language and translate it into the super precise logical language of math.
Take a look at this sentence. I mean, it's not a simple equation, right? It's a word problem. It's a puzzle. And before Femi can even think about solving it, he has to decode it. He has to turn these words into math symbols.
And here's exactly how he does it. You just have to break it down piece by piece. So, half of 8? Well, that just becomes 1/2 times 8. Simple enough. Then, the sum of and 3 means you take that first part and you add 3. Got it? And finally, the difference between 7 and tells you to subtract that entire thing from 7. See? Every word is like a command, a little piece of code.
And there it is. That whole tangled English sentence is now a clean, totally solvable math problem. Femi has officially cracked the final code. Mission complete.
You see, by solving that word problem, Femi didn't just get an answer. He showed he understood a core principle of how we have to talk to computers. With all 3 missions done, yeah, he won the challenge. But way more importantly, he and all of us just unlocked a key to understanding how our entire digital world really works.
So let's just quickly recap what Femi really mastered here. He learned to work inside the binary system, to translate numbers back and forth, to use a computer as a powerful tool, and, maybe the trickiest part, to translate our words into math.
So what's the big idea here? What's the takeaway? These aren't just random math skills. Each mission Femi finished was a step in a much bigger process. Altogether, these are the building blocks of what we call computational thinking. It's this amazing ability to look at a huge, complex problem, break it down into tiny, logical steps, and then say those steps in a language a computer can finally understand. It's probably the most important skill of the digital age.
And that kind of leaves us with one last really mind-bending thought. We just saw all the logic it took to translate one simple sentence. So just try to imagine the layers upon layers upon layers of binary code and logical steps needed for a computer to understand something way more complex, like a photograph of a beautiful sunset over Abuja. Kind of makes you think, doesn't it?